So when we look at radical expressions, we can start with the square root. So the square root or the principal square root always represents the length of the side of a square. Okay, so it always represents a non-negative value. So when we talk about the square root, it's essentially going from a square area to finding the length of the square side. Okay, so when we talk about undoing squares with square roots, we always have to consider that we're always going to end up with an absolute value term, because this value here, the square root, always represents a positive non-negative length. So if I were to evaluate something like this, the square root and square do not quite undo each other. Okay, so here, if they undid each other, I should end up with -3. However, this is not the case. Okay, so this is where we have to understand that the square root and square are not exact opposite or exact inverses of each other. So in this case here, when we square -3, we get +9, and when we square root 9, we end up with 3. Okay. Here, when we start with a positive value, we're going to end up, these will in fact undo each other, because when we start with +18 squared and square root it, we end up with +18. Okay, so in general, this is something we have to keep in mind, but in general, we can say that the root and the power undo each other. Okay, so this is something that we don't have to worry about with odd powers, but we do have to worry about this issue with even powers. So the power and the root will undo each other. So if I start with x, I power it by n and root it by n, I should end up with x. And since these radicals have something to do with powers, they are in fact the inverse of powers, so they must follow all the rules of powers. Okay, so they follow the same math rules as powers do. So let's take a look at mixed radicals and whole radicals, or entire radicals. Okay, so a mixed radical has a whole number part and the radical part. Okay, a whole radical has the whole value inside the radical. In fact, these two radicals are in fact equivalent to each other. 6 root 2 is equivalent to square root of 72. And we can type that into our calculator and we can actually see that that's actually the case. So one thing nice about mixed radicals is it's useful to do algebraic manipulations, because we've taken out the perfect square parts of the radical. However, when we talk about whole radicals, it's a little bit easier to compare whole radicals with each other, since we know that the magnitude of the argument inside the radical gives you an idea how big it is. So for example, square root 72 and square root 70, we can compare these two radicals with each other, because we know that we start with a square of area 72. Square rooting gives us a side length. Here we start with a square of 70, so this square is smaller than this square. That means that this side length must be smaller than this side length. So this is where whole radicals are useful, in that they are a little bit easier to compare with each other. But we do need to know how to convert from mixed radicals to whole radicals, and whole radicals to mixed radicals. So to convert an expression from a whole radical to a mixed radical, we need to look for perfect square factors. Okay, so in this case here, we have a perfect square of 9, so we're just going to rewrite this as 9 times 2x. Okay, as long as it's factorable, okay, we can't have pluses in there, but if there's a factor, that can come out of the radical. We can actually just split this up into square root 9 times square root 2x. Use a dot here. And this simplifies to 3 times square root 2x. So here, we're going to do the same thing. We're going to look for perfect squares, perfect square factors. So in this case here, for the number part, there is a 25 as a perfect square. So I'm going to rewrite this as 25 times 3. And with the x to the power 7, there is an x to the power 6, which is a perfect square. Now, if you're not sure about that, we could always just write it as x squared, x squared, x squared times x. Okay, so we can see that there are perfect square parts here, 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 and here. And that perfect square of x to the power 6, really, when we square root x to the power 6, we're going to have 1x, 2x, 3x, 3x to the power 3. So this ends up being square root 25 x6 times square root 3x, that's just left over. So square root 25 is 5. X to the power 6 gives us 1, 2, 3 x's, or x to the power 3. And then times 3x. So there is our whole radical or entire radical to our mixed radical.